Ambry's really excited that we were able to publish a paper in Genetics and Medicine that overviews the first 2,000 cases that we studied for multi-gene testing. And the lead author is Holly Leduca, who's one of the genetic counselors who works at Ambry, and she's part of our research team as well. And they really enjoyed going through the first 2,000 cases to determine what test was ordered, what the results were, and then what was the significance of those findings. Those tests are Breast Next, Ova Next, Cancer Next, and Colon Next. And so we designed these panels based on the tumor site, the location of the cancer that was most common in the family. So colon, breast, and ovarian were 3 of the panels, and then we had one larger panel that was all cancer types, or really breast, ovarian, and colon, those types of cancers all together in the same individual or same family. And at that point in time, Ambry was the only lab offering multi-gene cancer testing. So by us publishing this paper, we're really showing the world what we found in those first 2,000 cases. And that's something everyone's really hungry for, because we want to know, are these panels useful and are they worthwhile, or are they not? And what we found was they are quite worthwhile. So what a panel's allowed us to do is it's allowed us to look at all of the genes that we think are associated with a certain type of cancer at once. And this technology can provide a lot of comfort for the ordering clinician, because they know we're looking at all of the genes that are associated with what their patient's presenting with. And we're able to do this in a responsible manner and giving the patient results that are really meaningful. We went through the data for the first 2,000 cases. So we looked at the person, their demographics, so how old they were when they were diagnosed, what ethnicity they are, what types of cancer they've had, any additional testing or screening that's gone forth. And then we also looked at the family history. So we went through and determined who was what we called high risk, who had a more traditional high risk breast and ovarian cancer-like phenotype or presentation. And then we went through for the other panels as well and determined who met the criteria for your traditional high-risk colon cancer genes, etc. So what we found was that there was an increased risk to have a mutation in some of the genes on the panel that we would have never considered testing for in the past, or that would have taken us a lot of time and money to get to if we had done each gene individually. So by looking at the family histories and the personal histories and determining who was more likely to have a mutation and who wasn't likely to have a mutation, we're hoping that this information helps guide clinicians and genetic counselors and doctors in determining who is the most appropriate person for a panel test and how can they help their patients by offering them these multi-gene tests. Typically, if somebody does genetic testing for, let's say, a BRCA mutation, the positive rate's about 5 to 10%. If you do a panel, a Breast Next panel, for example, you're going to increase that detection rate by another 7 to 8%. So you're almost doubling the number of individuals who are identified to have an inherited form of breast cancer. And in that case, you have twice the number of people you can screen for breast cancer, you can prevent breast cancer in, and who you can inform their families of the disease risk. If you do a lot of genetic testing, you start to notice a trend in families that you think should have mutations coming back negative. And it's a dangerous thing to do, because if you test somebody for, let's say, a BRCA1 mutation or a BRCA2 mutation and they're negative, it's reassuring for them to not have that mutation, but at the same time, it's still scary because we don't know why there's breast cancer or ovarian cancer in that family. And so we're still cautious with that family and we're still following them at high risk. And it's really frustrating because the family wants to know, why do they have cancer and who else is at risk? And do I have a risk for a different type of cancer as well? So by using multi-gene testing, we're about doubling the likelihood of finding this mutation. One of the most common concerns is a variant of uncertain significance. And people estimated that our variant rate could be very high because some of these genes haven't been tested for clinically very much in the past, so they're some of the more recently described genes. So our publication shows you exactly what the variant rates were for the 4 first panels that we started offering. And people were surprised and pleased to hear that the variant rate was a lot less than they had initially thought it would be. For example, our Breast Next test looks at 18 genes that are attributed with inherited breast cancer, and our variant rate for that test is 18%. And that's a higher number than if you just tested BRCA1 and 2, but it's not nearly as high as it could have been. And so physicians and genetic counselors are a little bit more confident in ordering these panels because they know at least 80% of the time they're going to get a black and white yes or no, you have a mutation or you don't, and it's less than 20% of the time we're going to find an alteration in that gene that we aren't exactly sure what it does. And with that, we're able to help more people identify the cause of cancer in themselves and in their families. Traditionally, if you would have ordered BRCA1 and 2 testing, you might have then added on a single gene, like a P53 or a P10, two of the more common breast cancer genes after BRCA1 and 2. But that typically requires the patient to come back to the office. You're going to draw blood or collect saliva again, and then we're going to bill insurance or collect money from the patient. So the more genes you test, you can see it will just add up on time and money that it takes to get these results back. So by using a multi-gene test, we're able to look at several genes that all cause the same presentation at the same time. And we're really producing a product that's a better test. It identifies more mutations, and we're able to do it in a more timely and more cost-effective nature. And so the patients are starting to really appreciate this option, not only for the medical implications it provides their family, but also for the time and cost savings it provides them. One of the things that we were looking at when we developed these panels was to figure out how often we would see mutations in situations where we weren't expecting them. So for example, say we thought a patient had a disease called Lynch syndrome, and instead we found a mutation in a gene called P10. Because when we do gene testing, gene by gene, we often don't order the gene that we don't think the mutation's in. We always order the genes where we think we're going to find something. So specifically in our colon cancer patients, we went back and we looked at how many individuals with colon cancer that had the Colonex test, which is a test that looks at 14 genes that cause colon cancer. How often do one of these individuals have a mutation in a gene we would not have expected? And we used national criteria to determine who met the criteria for the gene we identified the mutation in and then who did not. About 30% of the time, we found that individuals had a gene mutation in a gene that they didn't meet the criteria for. So although they had colon cancer and it looked like an inherited form of colon cancer, 30% of the time we wouldn't have offered testing in the appropriate gene. So using a panel like Colonex can be helpful if there's a family history of colon cancer and you want to make sure you're capturing all of the potential gene mutations.